Okay, welcome to Unit 7. It's not a long unit, and it's pretty new stuff though for us. So we're going to take a look today at trigonometry, and we're going to start by introducing you to a mnemonic device that you're going to want to commit to memory called that we refer to as SOHCAHTOA. Okay, SOHCAHTOA is a mnemonic. It's a tool for remembering this relationship that exists over here down the left side, this sine, cosine, and tangent relationship, and how they relate to the opposite, adjacent, and hypotenuse of a triangle, depending on which angle we're talking about. We'll get a little bit more specific as we go, and it'll sort of help with understanding the information. So let's take a look, for example, at sine. The sine relationship is equal to, or the sine of an angle A is equal to the opposite leg over the hypotenuse. So the sine of angle A right there is equal to the opposite side, which is lowercase a, over the hypotenuse, which is lowercase c. Okay, it's really important to remember that lowercase letters are sides and capital letters are angles. Okay, so now we have the sine of angle B. So let's take a look at the sine of angle B. Angle B is here. So the sine of angle B is equal to the opposite side over the hypotenuse. Again, that looks like an H, but it's actually a B. So the sine of angle B is lowercase b, and again capital C, or lowercase c. Okay, lowercase b over lowercase c. Okay, so those are the two relationships for sine. Cosine, and let's do this also. Let's put sine is equal to opposite over hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. Alright, so if we look at the cosine of angle A is here. Adjacent means next to. There are two sides next to angle A, B and C. Well, C is also the hypotenuse, so we know that that's not it. So we know that the cosine of A is the adjacent side, so this B, over the hypotenuse, which is C. So there's that. The sine, or I'm sorry, the cosine of B is the adjacent side, so this side next to it right here, which is A, over the hypotenuse, which is C. So those are the sine and cosine relationships. Tangent is just the opposite side over the adjacent side. So when we look at the tangent of A, the opposite is A and the adjacent is B. We're not going to have C at all. Okay, so we have B as the adjacent side of A, and we have A as the opposite side. So that's the tangent, is A over B. And then for the tangent of B, it's just the opposite of that. The tangent of B is opposite over adjacent, so B over A. And again, these are just the relationships that exist. These are all fractions. They're the ratios that exist between tangent, cosine, and sine. So let's take a look at this. Some of the stuff in the notes packet, I apologize, it got copied before I could fix this. So some of these mistakes you're going to want to correct. That's a 5, A, B, and C. Just check to make sure your sides and your letters are the same as mine. So take a second and see if you can fill in the sine of A, B, and C, the sine of A, B, the cosine of A, B, tangent of A and B. For these two triangles, go ahead and pause the video right here, take a second and see if you can fill all those in correctly. Okay, just like that, I made some boxes appear because I have those kind of powers. Let's take a look and see what you did when you had the video paused. The sine of angle A, the easiest way to think of this is, and this is how I'll tell students to set it up sometimes, is you want to circle the angle you're working with. So we're looking at angle A. And then according to angle A, this side is opposite, this side is adjacent, and that side is the hypotenuse. Once we get those, the executing the problem is actually pretty easy. The sine of angle A is opposite over hypotenuse, so that's 4/5. The cosine of angle A would be 3/5. And the tangent of angle A would be 4/3. The sine of B, well, let's change colors here and make sure we're looking at the right thing. B disregard this announcement. Miss Wesselhoff, please call extension 27, blah, 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 blah. Okay, so there's B, and then so from B now, and again, I know we have OA and H there for red, but those were for angle A. For B, the opposite side is now 3. The adjacent side is 4, and the hypotenuse is still 5 right there. So let's take a look then at sine of B should be 3/5. The cosine of B is 4/5, and the tangent of B is 3/4. We do the same exact exercise, or the same exact mental stuff here for A. This is O, A, and H. And students a lot of times like labeling these because it gives you kind of a reminder of, all right, when I'm talking about B, this is the opposite side from B. That's, whoopsie daisy. That's the adjacent side, and there's hypotenuse. For those of you that have been watching all the videos, you'll know that despite my efforts not to, I cannot seem to stop myself from saying whoopsie daisy. Funny, weird thing I do. Okay, sine of angle A is 12/13. The cosine of angle A is 5/13. And the tangent of angle A is 12/5. The sine of B, 5/13. The cosine of B, 12/13. And the tangent of B, 5/12. All right, let's take a look at the next page. So some basic problems, basic trig ratios and calculator use. Again, check your triangles to make sure you have the same kind of numbers and letters and setup that I have. Sometimes you're given lengths of 3 sides of a triangle, or in this case, we're only given 2 sides, but using Pythagorean theorem, by the powers vested in me, I can figure out that the missing side there is 12. So 12. If you don't know how I got 12, then you need to work on Pythagorean theorem and probably retake the Unit 6 test. So just setting up the ratios. If I see the word ratio, I know right away that the question is looking for a fraction. So I'm just going to try to set up some fractions for these problems. Okay. So for example, sine of angle A. Well, we're referring to angle A in all of these. So let's go. Here's angle A. So the hypotenuse is here, the opposite side there, and there's the adjacent side. Well, the sine of angle A is 16/20. I'm never going to leave this as 16/20 because my teacher knows that I know how to reduce, and so I want to show off. So what number goes into both? And it's 4, and so we get 4/5. All right. The cosine of angle A is 12/20, but that also can be reduced to 3/5. And the tangent of A is 16/12, which can be reduced to 4/3. Same over here. Okay, we have x. So there's x. That's the hypotenuse. That's opposite, which makes that adjacent. The sine of x. And again, it's really useful. The more chances you have to write out SOHCAHTOA, the more times you write it, the more likely you are to remember it. And that's sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. So the sine of x is the opposite side over the hypotenuse. That's 15/17. The cosine of x is 8/17. And the tangent of x is 15/17. Easy enough. Another kind of problem is you're given an acute angle measure, and you have to find, as a decimal, the sine, cosine, or tangent ratio in relation to that given angle measure. There's some calculator stuff here. Those of you holding out and still not buying a calculator, a graphing calculator for yourself, you are going to really struggle to pass anything we do this unit because the calculator usage is really important. First, it's a big deal that your calculator has to be in degree mode. Okay, and that's different for each of you depending on whether you have a TI or a Casio. I have a Casio on my computer right now, but if you need me to show you how to do it in a TI, I can do that also, or your teacher can take care of that for you. So I'm going to go into my Casio, and from the regular run menu, I'm going to hit Shift Menu. And from there, I'm going to scroll down here to angle and just change it to degrees by hitting F1. Okay, I hit execute and I'm all set. If you have a TI, just hit mode, scroll down and take it out of radians and put it into degrees. All right, but these are pretty simple problems, and it's very simple in your calculator. These three right here. I'm literally just going to push the tangent of 50, and then I'm going to hit enter, and that's it. Okay, round to 4 decimal places, so this is 1.198. Okay, take a second and see if you can do 2 and 3 on your own. I'm going to pause the video. You should pause the video right here. Try 2 and 3 on your own. Okay, I've unpaused, hopefully, or you've unpaused. Hopefully you got the same answers I did. Again, I just typed in exactly what it said, and I got 0.8829, and I got 0.7218. Okay, pretty easy as far as calculating those. A, B, and C are a little bit different. We have to do a little bit of work here. We're going to cross multiply, so we're going to set these up. I'm going to do the same thing every time because I like getting it right. This is the angle that we're working with. So this is the opposite side, this is the hypotenuse, and this is the adjacent side. And then I have to make some decisions based on this. Okay, I've got to decide, of my 3 choices, sine, cosine, and tangent, which should I use? Well, in this problem, I don't know anything about the h. I don't have a letter on it, I don't have a variable, I've got nothing. I've got no number, nothing. So I can't use h. The only 2 sides I have anything for are o and a. And the only trig function that has o and a only is tangent. So I know that the tangent of 34 is o over a, or a over 8. Alright, I'm going to set up all 3 of these and then we'll come back and do the calculations. Over here on part B, I'm working with this angle, this is opposite, this is hypotenuse, this is adjacent. Now I have an O and an H. Well, the only choice with O and H is sine. So the sine of 56 is B over 20. And then over here all the way on the right, there's my angle, that's opposite, that's adjacent, that's hypotenuse. O and A again, I remember that one, that's tangent. The tangent of 47 equals 4 over B. And so then I'm just going to cross multiply each time, and I'm going to use my calculator to do that. Some pretty simple calculations here for us. The tangent of 34 times 8 divided by whatever, which we know is a 1. So this, I'm going to multiply diagonally and divide by what's left. So the tangent of 34 times 8 is all I have to put in. So 8 times the tangent of 34. It didn't tell us where to round on this one, so we'll just round to the 10th. So that's A equals 5.4. Let's look at this one. Sine of 56 times 20 divided by 1. So sine of 56 times 20. Let's do that. Sine of 56 times 20 is 16.6. And then over here, this one is slightly different because we're going to divide by the trig function. It's 1 times 4 divided by the tangent of 47. So B is going to equal 4 divided by the tangent of 47. And if that's confusing you, then you need to talk to your teacher about how to cross multiply correctly and effectively in these problems. But that's 3.7. And that's it. Okay. Let's take a look over here. You're given as a decimal or fraction the sine, cosine, or tangent ratio in relation to an unknown angle. You have to find the measure of the angle. Again, make sure that your calculator is in degree mode. Okay. Here we're going to use what's referred to what's called the inverse function. You'll notice on your calculator the inverse function is above sine, cosine, and tangent in a different color depending on what kind of calculator you have. So you're going to use your shift or your second key here if you have a TI. But really, these are really quick and easy problems. You just have to know the ratios. Here, instead of giving us a ratio, they're actually giving us the decimal. So all I have to do is take the inverse of each side. So I'm going to take shift sine, and then I put in the number exactly, 0.1239. I hit enter, and it says round it to the nearest tenth. So that is 7.1, and that's it. Okay, P, the angle. Here we're finding the angle. So P equals 7.1. Go ahead and pause the video right here and try to do a couple more on your own. See if you can figure out what these angles are. Okay, so that yeah, try 2 and 3 on your own. Okay, we're back. There's the answers that I got. M equals 45.1 and A equals 36.9. Hopefully you got similar answers. Here's my calculator. You can see, so you can see what I did. I just pushed second or shift, depending on your calculator, cosine 0.7064, enter, and I got 45 point this, so I rounded to 45.1. And here, shift tangent, and then 3/4, I actually used the fraction button. It's important to put that in correctly, so either use the fraction button or use parentheses to put 3/4 inside the parentheses so that the inverse function works correctly. Okay, let's take a look at these triangle problems. Same exact idea right here. So same idea, except for it's not, the ratio is not given to us. So I need to, here's the angle I'm talking about, and just ignore that. That's really rude. I asked them to stop doing that, but they just won't listen. Here's opposite, adjacent, hypotenuse. Let's go and label them all. Here's the angle. There's opposite, adjacent, hypotenuse. Here's the angle. On this one, there's lots to do. We could do either angle. I'll choose this one. We know that this one is 50 because we know facts we know about a triangle. So let's do this. Let's just work with the angle that's a number. So there's opposite, adjacent, and hypotenuse here. So let's go through now, and literally these just become calculator problems once you can figure out which trig function to use. So we know nothing about the a. So if you're looking at Sacagawea's estranged sister. It's a long, sad story that we don't have time for right now. So O and H has to be sine. So this is the sine of x equals 3/9. We'll set them each up first. Set all of them up, and then we'll do the calculations. Here we have A and H. That's cosine. So the cosine of x equals 5/13. And here we can do, we'll do the, we have four. We have three sides. There's more than one variable here. There's lots to do. First, we know that this is 50 because 90 plus 40 plus 50 is 180. So then we can do, we'll do the sine of 40 equals 4/b, and then we'll do the cosine, the tangent of 40 equals 4/a. So we have two things to figure out there. Alright, and then let's get into our calculator and start figuring these things out. When we're looking for the angle, that's when we're going to use the inverse function. So inverse sine, and then I'm going to put 3 fraction button 9, 19.5. So x equals 19.5. Okay. Over here it's 5/13. So again, because we're looking for the angle, it's shift cosine, and it's 5/13. And that is 67.4. And then over here, we're not looking for the angle anymore, so we're not going to use shift sign. We're gonna cross multiply. So this is over 1. So over 1, and I multiply diagonally what I know, and I divide by what's left. So the sine of 40 is it's 1 times 4 divided by the sine of 40. So 4 divided by sine of 40. And that's 6.2. And then it's 4 divided by the tangent of 40. And that's 4.8. Okay. Then down below, there's just some strategies that gives you, look at the information to see what you're given and see what you're asked to find, so that you know whether to use a trig problem, whether the problem is a trig problem or a Pythagorean theorem problem. Right here, number 4 says, if you're given the lengths of two sides of the triangle, and you have to find the third side, is that a trig problem or a Pythagorean theorem problem? And that, of course, is a Pythagorean theorem problem. Okay. Once we're given two sides of a right triangle, we're looking for that missing side. That's a Pythagorean theorem problem. Let's take a look at the next page. So these problems here, none of these are trig problems. These are just Pythagorean theorem problems. These are right triangles missing a side that you have to calculate or solve for. So go ahead and take a second, work on your Pythagorean theorem skills, pause the video so you don't get the answers too fast, and see what you get. Sorry, some of you are wondering how to do the second one if you've had it paused. That's a 14, it's not a 1. Back to work. Okay, so you are ready to check your answers. I've made the little red boxes appear again, so look at me. On this first one, pretty easy one. It says round to the 10th. Here we don't have to. X equals 5. Here we have 12.6. And here we have 9.8. Making sure that the longest side of each triangle is the hypotenuse, and that is the side across from the 90. Number 5, you're given the measure of an acute angle and the length of one side. You have to find the length of another side. What kind of problem is that? That is a trig problem. Okay, so your variable is on the top of the ratio. So let's set these all up. Here's our angle. This is opposite and adjacent. We don't know the hypotenuse, so this is tangent. Okay, let's write this out so my chances of remembering it increase. So this is the tangent of 42 equals x over 9. Here we have this angle. This is opposite and hypotenuse, so this is sine. The sine of 51 equals x over 4. Here, this is opposite and hypotenuse again, so sine of 65 equals x over 21. Take a second, pause the video again, and let's see if we can get some correct answers here using the trig functions in our calculators. Okay, let's see how you did. For the tangent of 42, you should have got x equals 8.1. For this problem with sine and 51 and x over 4, you should have got 3.1. And for here, you should have got 19.0. Real quick look at my calculator. This is how I did these problems. Tangent of 42 times 9, sine of 51 times 4, and the sine of 65 times 21. All right. Let's take a look at when your variable's on the bottom of the ratio. That's when we're going to divide. So let's set these problems up. This is opposite hypotenuse. This is opposite and adjacent. This is adjacent and hypotenuse. So let's see. This is sine of 40 equals 39 over x. This is the tangent of 35 equals 10 over x. And this is the cosine of 78 equals 4 over x. Now remember, these problems are a little bit different because when you cross multiply here, you're going to multiply 1 times 39 and divide it by sine of 40. Okay, 1 times 10, so just 10, divided by the tangent of 35, and then the same thing here. Go ahead and pause the video again and try these problems. All right, let's see how you did. Tangent of 42 equals x over 9. You should have x equals 8.1. Here, x equals 3.1. And 19.0. Another look at my calculator. This was 39 divided by the sine of 40. Okay, I just showed you the wrong problems, didn't I? Let's scratch that and reverse it. We're down here. Whoopsie. Here we go. X equals 60.7. I closed my calculator too, so you can't see these calculations now. Look, I've done you harm, and for that, I'm truly sorry. If there's any way I can make it up to you, like for example showing you how to do all your math problems, you just let me know. Here we would have done 39 divided by the sine of 40. Okay, so that's how I got 60.7, and then the same method for finding x here and here. All right. Let's take a look at the bottom one just as a quick reminder. What if we're given the lengths of two sides and you have to find the measure of one or both of the acute angles? So here we have to find the measures. Let me get you an accurate side there. There you go, 14 on that side. So let's go ahead and find the relationships here. We're working with this. That's O and H. That's O and A. And here that's O and A. So let's find some angle measures. Okay, we're going to use sine here, so sine of x equals 9 over 13. The tangent of x equals 8 over 12. And the tangent of x equals 15 over 14. Now remember, this is when we're doing the inverse function. I'll walk you through and remind you how to do the first one because this is the one that's different. Okay, it's the one that requires that extra step in our calculator. When we're looking for the angle, anytime we're looking for the angle, we use the inverse. So inverse sine, and then I'm just going to put the numbers in as the fraction that they already are. So 9 fraction 13. I know that some of you have a TI, and the TI it looks a little bit different. So it's 43.8 here. X equals 43.8 0.8. In the TI, I think it automatically gives you parentheses. That's no problem. Here for this one, I'll show you. It looks like this. Shift tangent, and then it automatically opens up some parentheses. You'll just put 8 divided by 12, and then close the parentheses, okay? And that's 33.7. And then the last one, tangent is the only ratio that can be greater than 1, because the other two ratios have the hypotenuse on the bottom, and neither leg can be bigger than the hypotenuse. A little bit of trivia there for you. You're welcome. 15/14, and that's 46.9. To round that to the 10th, it's technically 47.0. Okay? It says, let's just erase that. That's god awful. We don't want to end on that note. X equals 47.0 to the 10th, so we have to have a 10th. There it is, folks. 7A. Hope you enjoyed. Hope it wasn't too painful. Hopefully you paused it and didn't cheat, because if you did, shame on you. If you didn't, God bless you. You're a wonderful American. See you guys in class.